Alright, so today we're looking at factoring special products. When we were looking at multiplying binomials, we had special binomials that we were paying attention to. So for example, we looked at something like the following. We said that if we have something like x plus 9 times x minus 9, what would happen to those middle terms when we boiled or distributed? They would cancel out, no? They would go away? Well, no, you're thinking factoring. We're talking about before factoring when we distributed. We were talking about special products, special binomials, special products. And we said that if you have two terms that are the same, but opposite signs, the middle term that we normally have cancels out, and you're just left with x squared minus 81, right? So now it's just going backwards. It's saying that if we have two squares, yeah, if we have two squares, so if I have an x squared, two perfect squares, so the square root of x squared is just x, and the square root of 25 is just 5. So I have two perfect squares and I'm subtracting them, and the result is this. Yeah, so we're just going backwards. So for the first one, is this back to the following, x squared minus 25. So I look at that, and I want to factor it. So I notice right away that I have two perfect squares. A number times itself will lead to a square. I have an x squared and I have 25. So because I have two perfect squares, my resultant is x minus 5 times x plus 5. See how I'm going backwards to that special product that we talked about a while ago instead of 5 or 4. X squared minus 9. So I have two perfect squares. I have an x that's squared. I have a 9 that's squared. So that becomes x plus 3, x minus 3. If I ask you to multiply this, if I say multiply the polynomial, if I say multiply the binomial, then you should know, because of special products, that this is what you're going to get. Yeah? So it's about using those rules, and I know it's a little confusing. It's about using those rules and being able to see them forwards and backwards. That's going to take a little bit of time, but with practice, hopefully you'll get it. Do you have any questions? Okay. I want to give you more time to work on homework today. Alright, so let's look at this. So for this first one, I'm asked to factor. I'm not asked to multiply anything, I'm asked to factor. So I noticed right away I have two perfect squares. 4 is a perfect square, right? Z squared is a perfect square, and 1 is a perfect square. So when I'm subtracting two perfect squares, I remember my special factoring rules, which says that I just square the first term, or square root the first term, which just gives me 2z, and I square root the second term, which just gives me 1. And so what I end up having is 2z minus 1, 2z plus 1. And that's just something that, at this level, you just memorize, yeah? You say, if I have two perfect squares and I'm subtracting them, and when I factor, I get the square root minus and the square root plus. Does that make sense? And keep in mind, you're squaring the entire term, so they have to, whatever's attached has to be part of that perfect square. So for example, if you get something like 9 over 4 x squared minus 4, that's another example, right? 9/4. If I take the square root of that, what do I get? Yeah, 3 over 2. And then I take the square root of x squared, I just get x. So 3 over 2x minus 2, and 3 over 2 plus 2. And when I FOIL that, or I use distributive property, I end up with this. The middle terms canceling out, and just having a minus 4. Do you have any questions so far about special factors and how we get special products from special factors? Okay, so the next thing that we have to look at are just numbers. And this is just something that I'm just going to throw out there just to let you see how we can apply this to other larger numbers. So let's say you're given a situation like this and you're just hurrying along. It's a no calculator portion or something like that, and you want to figure out how to do something like this relatively quickly. Well, the nice thing about all of these rules is that they can apply to just our numbers alone and to our arithmetic, right? So in this case, I have two things that are squared, a 54 squared and a 48 squared. So if I take a 54 squared and I square root a 54 squared, what do I get? What happens to the square root and the square? They cancel out, and you just get a 54. What happens to, if I take the square root of 48 squared, what do I get? 48. So the shorthand of this would be 54 minus 48 times 54 plus. So when I do that, I get 6 times 102, which will give me the answer, which is 342. 54 minus 48. Yeah. Does that make sense how I use that shortcut? Again, do you need to know this? No. They're teaching this trick to the younger grades now, so this is something that you guys are just slightly older, so something that you may not have been exposed to, and that's fine. I just want to show you just a quicker way to do something like this. I am more going to make you accountable for something like this, just to set you up for the skills that you're going to need in Algebra 2. But that is a trick, and for some of you who think in that way, you can use those tricks with the special factors to help you. Yes? 54 minus 48 is 6. 54 plus 48 is 102. Multiply them together, you get 342. Yeah? Any other questions? Okay. Go ahead and factor these. Let's check to see how you did, and if you didn't get these, let me know which ones you need to see. Well, huge. Did you get those? Okay, good. I don't know what I was thinking this morning when I enlarged that image. But, there you go. Okay, good. Now, on your test, all right, now that we've looked at those answers, let's move on. Okay, perfect square trinomials. If you need me to read that, I will, so that you can see if you're in the back. Okay, so I'm going to talk about this. Perfect square trinomials. We talked about this when we were finding products, special products again. We said before, let's say, I wanted you to find that. Now the temptation is from now until forever with mathematics, the temptation is to say that that equals a squared plus b squared. We do not want to do that because that's not true. trig students are doing that. I don't want algebra students doing that, and getting to trig and doing that. So let's not. Let's remember that if we have a plus b quantity squared, what we're really doing is we have that middle term, and I talked about that last time. I said that that is a squared plus 2ab plus b squared. Remember that? And then the only difference between that and this was that that middle term, that middle 2ab is subtracted, but the ends are both positive. So you end up with a squared minus 2ab plus b squared. Now, of course, factoring is reverse distribution, so it's going backward. It's saying, hey, I'm given something that's a squared plus 2ab plus b squared, then I should recognize that that's just a plus b squared. Or I'm giving something that is of the form a squared minus 2ab plus b squared, so I should know its factors to be a minus b quantity squared. So how do you tell? Well, you just take the first term and the last term and see if they're perfect squares, as usual, which they are. So you have a first term that's a perfect square, you have a last term that's a perfect square. You take those square roots and you can see what those are. The square root of n squared is just n. The square root of 16 is just 4. And then that's your a and b. Now, the other thing that you want to do is make sure that that middle term is twice ab. So a times b is 4n. Twice that is 8n. The middle term 8n. Yes, it is. So that means that this factors down to b. And we see n squared plus 8n plus 16. That is going to factor out to be n plus 4 squared. Does that make sense, what I did? Kind of? So like, let's look at this example here. X squared minus 6x plus 9. First term's a perfect square, last term's a perfect square. Take the square root, I get 3. Middle term is minus 6. Well, 3 times x is 3, double that is 6, so that doesn't work. So that factors out to be x minus 3 times 3. It's just going to take some practice. I know that moving forwards and backwards is a little bit of a mental exercise, but you will get it. Okay. Questions? Okay. Let's try B. If you think you know what to do, go ahead and solve it. Okay, so the trick for me, if I were you, and I were going to take this test, or I was going to take this test, I would be looking for perfect squares. Anytime I see perfect squares, then I know I have some sort of special factoring rule. So any of them that I'm given, just like, oh, pull out the GCF first. Well, I'm also going to be looking for perfect squares. Well, that doesn't have a GCF, so I can't pull anything out. Does it have perfect squares? Yes, the 4 is a perfect square and the 9 is a perfect square, so that indicates to me that some special factoring rule is going to apply. And at this level, hint, hint, if you see something like this, perfect square in the beginning, perfect square in the end, I mean, you should know that it's going to be a minus b squared. Yeah? So, in this case, I have a 4x squared, that's a perfect square. I have a 9, that's a perfect square. So that is a special factoring rule. So in this case, I'm going to take the square root of 4x squared, and I get 2x. I'm going to take the square root of 9, and I get 3. 3 times 2 is 6x, double that is 12. That works. So that means that this factors down to be 2x minus 3 squared. So it's a minus b squared. So this is the a, and this is the b. The square root of this. Do you have questions? All right, so let's look at the next one. Do I have perfect squares? I do. 1/3 times 1/3 is 1/9, right? So that is a perfect square. 1 is a perfect square. So 9 is a perfect square. So I take the square root of x squared, and I get x. I take the square root of 1/9, what do I get? 1/3. So I multiply them together and double it, see if I get that middle term. 1/3 x, double that is 2/3 x, so that works. So that means that this is a plus b squared. So a plus b squared, x plus 1/3 squared. Well, isn't that a double root? Because it's the same thing in parentheses. And if I have you solve it, like on the quiz yesterday when I said solve, I wanted you to set it equal to 0. And I say find the roots, set it equal to 0. So when you do that, you'll set the same thing equal to 0, so you get a double root, and that double root is 0. Now you get 1/4. Okay. Is this good? Is it too much? I feel like you got it. Okay. Cool. The fear that I have is just like last time when I taught factoring with the bottoms up method and the box method and everything, a lot of you forgot that something like x squared plus 5x minus 6 didn't require you to do the bottoms up method, it just required you to make an x, yeah? And some of you forgot that if you have a GCF, to pull out the GCF. So if I just multiplied everything by 2, and I got 2x squared plus 10x minus 12, some of you just did this without pulling out the GCF. So please don't forget these things. Like I know it's good in a vacuum, but you want to make those connections. Right. All right. Do I notice perfect squares? Yes. I do. A 1 and a 1. So I notice perfect squares and I have a middle term. So I'm going to, step 1, take the square root of those perfect squares. So the square root of m squared is m. The square root of 1 is 1. When I multiply those two terms together and double it, do I get the middle term? I do. So what that means to me is that it takes a very specific form. So that form will be, and because it's minus 2m, it's going to be m minus 1 squared. What is this? Second, do I notice perfect squares? I do, yes.
How do you know this? How do you know if it's going to be minus one?
This. If there's a minus, it's going to be minus. If there's a plus in front of that middle term, it's going to be plus. Okay, so you told me that you noticed perfect squares on number 10. So, again, I'm going to take the square root of d squared, and I get d. And then I'm going to take the square root of 25, and I get 5. So, that's going to take, again, another specific form. 5 times d is 5d, double that is 10d. Do I get that middle term? I do. And because it's a minus in the middle, it's going to be d minus 5 squared. Does that make sense? Third one. Do I notice perfect squares? What else do I notice? A GCF. So, very first thing before I take the square root is I have to pull out the GCF. That's always step 1, no matter what. So step 1, fill out that GCF. So, I can pull out a 9, and I end up with z squared plus 4z plus 4. Do I still have perfect squares? I do. Right. And then, so what I want to do now is I want to take the square root of z squared and the square root of 4. The square root of z squared is z. The square root of 4 is 2. Because there's a plus, It's going to be C plus 2 squared. Do you understand 9, 10, and 11 now? Okay. Now I just have a few extra steps on 12, 13. Can I erase this? Okay. Okay, number 12. Do I notice perfect squares? Yeah. 1 and 9. Square root of a squared is a. Square root of 9 is 3. 3 times a is 3a. Double that is 6a. That works. So it's going to be of the form a plus 3 squared equals 0. I should know automatically I get a double root because of the square, so my answer is a equals negative 3. Okay, the next one. Do I have perfect squares? I do. So I'm going to take the square root of w squared. And the square root of 49 over 36, which gets me what? 7/6. When I take 7/6 times w, and I double that, does it reduce to give me 7/3? And it will, yeah. So now I just have w plus 7/6 squared, or w minus. W minus 7/6 squared, I have a double root, w equals 7/6. Last one. What's different about the last one? Do I have a middle term? No, so this goes back to the first example. I still have perfect squares, and remember how I said I don't want you to forget the little things? This is one of those little things again. So now that we're going on to this, don't forget this that we just learned in the first couple slides. So I have perfect squares. My perfect square is n squared is n, and 81, which is 9. Well, I know that I have, if I have a squared minus b squared, I end up with n minus 9 times n plus 9. The middle terms cancel out. So that's this one. Does that make sense? This is what we were doing a couple slides ago. We were looking at these, right? So no middle term. So if I don't have a middle term, then again, that just indicates to me that it's going to be plus and minus. Okay, any questions? Okay, we're done. So, let me give you your assignment. Here's your homework. 16 items.